Welcome back, everyone. So we stopped at this part of memory. We discussed how the things that we want to remember we often forgot, such as the color contrast, that for yellow and uh, see, I forgot it. But for the trivial ones, we often remember those. But yeah. The continuation is this filtering process, however, is not without its problem. Yeah. How does the filtering process works in working in long-term memory? Initially, encoding takes place, determining which information is paid attention to in the environment and how it is interpreted. The extent to which it takes place affect people's ability to recall that information later. So this is what I'm saying. The place and the intensity of the learning experience determine how you would process it later. So first, to be able to understand your surroundings, you need to perceive it. You need to hear it. You need to sense it through touch, which allows you to use your memory. For example, when learning about a topic, it's much better to reflect on. So we reiterate this because it's such an important concept that we explain, reiterate, and basically actively work on the information to be able um, to be able to put that in our long-term memory. Thus, how information is interpreted when it is encountered greatly affects how it is represented in memory and how easy it is to retrieve subsequently. Another factor that affects the extent to which information can be subsequently retrieved is the context in which it is encoded. One outcome is that sometimes it can be difficult for people to recall information that was encoded in a different context. So we've discussed that in the previous video. People are good at remembering visual cues about things. For example, the color of items, the location of objects. For example, a book being on the top shelf and marks on an object like scratch on a watch, a chip on a cup, and so on. So we are better to remember this color that seems to distinguish with other color or other objects that we use in our daily lives. So the key thing here is that the it distinguished because some colors become distracting, as we have learned in the previous uh, topic. In contrast, people find other kinds of information persistently difficult to learn and remember, especially arbitrary material like phone numbers. Then we'll go to savings and saving files. The number of documents written, images created, music files recorded, video clips downloaded, emails with attachments saved, URLs bookmarked, and so on increases every day. Many people now store their files in the cloud or on hard drive with view to accessing them later. This is something known as personal information management. A design challenge is deciding how to help people organize their digital content so that it can be easily found. For example, via folders, albums, or lists. In particular, how can they access specific files at later date, such as photo they took of their dog spectacularly jumping into the sea to chase a seagull, which they believe was taken 2 or 3 years ago. It can be difficult to track down, especially among thousands of photos of their dog. So, because of these capabilities that computer allow us, it allows different formats of data as well, such as music files. But without music files, we won't be able to listen to music. Without image, we won't be able to capture moments. Without emails, we won't be able to communicate to far out or far location. And without video clips, I don't know what's our entertainment is, right? So the same challenge is deciding how to help people organize their digital contents. Um, do they start horning in on a folder for a given year, looking for events or places, or do they type dog at sea in their photo album search box? Most people will try one or the other or both, depending on the nature of what they are looking for. Although there is a preference for scanning across and within folders when looking for something. Spotlights. So basically, people become used to searching for files. So whenever they want to search for their files, they use folder, even though that's not the most efficient way to search. So Spotlight enables someone to type a partial name or event or even the first letter of a file that it then searches for throughout the entire system, including the content inside documents, apps, games, emails, contacts, images, calendars, and applications. Picture below show a partial list of files that Spotlight match to the word cognition, categorized in terms of documents, mail, and text messages, PDF documents, and so on. So here, it was able to get all the result for the partial word cognition. So this is helpful, especially for trying to access things in a time critical manner, which most jobs require nowadays. Most knowledge work job. So basically, what you want is a system that allows you to search partially and uh, that it's easy to retrieve, that you are easy to make sense of it. Basically, the context here is that since you need to focus, you need to make sense of the searching. You could the searching could be so long that the method that you use is not the right algorithm or the right method. So the key here is um, to understand that for searching files, icons such as like folder comes easy to people, and then there's a system like this that allows you to search for partial keywords. Google search tools also develop many advanced features which are geared toward making it easier for someone to find the information or image they are looking for by analyzing their query or keywords and ranking potential relevant results. So here, AI has also been added to the mix to help narrow down possible image that someone might be looking for. For example, the search tool QuickFind uses ML algorithms to identify common objects such as cats, dogs, mountains, etc. Despite these advancements to search tools, many people still prefer old-fashioned way of using folders for storing their files and digital content. Another thing here is that the study of cleanliness in our digital folder. So just like everything, or just like in your house, you need to always prune your files. So you need to delete files that you don't need so that it's clean, because that process of cleaning will actually allow you to know the right storage system. So it allows you to be organized, and it allows to be more efficient when you retrieve that file moving forward. So in remember, in focus or attention principle, you have a clear goal, but to be able to get that faster, you need to create an environment that remove those distraction in your files. So basically, you're trying to create a salient information, don't distract with too much information. So you need to delete files. That's a key with this. One reason is that folders provide powerful metaphor that people can readily understand, placing things that have something in common into a container. A folder that is often seen on people's desktop is one simply labeled stop. This is where documents, images, and so forth that don't have an obvious place to go, but that people still want to keep somewhere, are often placed. Offer Bergman and Steve Whittaker 2016 suggests that helping people manage their digital stuff better by deciding what personal information to keep, how to organize the information when storing it, which strategies to use to retrieve it later. They suggest providing richer metadata tools such as time stamping, categorizing, tagging, attribution, for example, color, text, icon, sound, or image. So this another thing which we will discuss in the later part is the stamping or tracking. So this is another tool that allows you to track your the time that you created the files, because that helps a lot. And then categorizing, tagging, and attribution. For example, color, text, icon, sound, or image. So you have to experiment. But these are the strategies. You can categorize it using dates, or you can categorize it via its color, or text, or icon, sound, or image. The problem with magical number 7, plus or minus 2, perhaps the best known finding in psychology, certainly one that nearly all students are remembers years after they have finished their studies, is George Miller's 1956 theory that 7 plus or minus 2 chunks of information can be held in short-term memory at any one time. However, it's also one that has been misapplied in interaction design, because several designers assume that it means they should design user interfaces only to have 7 plus or minus 2 widgets on screen, such as menus. By short-term memory, Miller meant memory store in which information was assumed to be processed when first received. By chunks of information, Miller meant a range of items such as numbers, letters, or words. They're able to remember only a few words or numbers they have heard or seen. So this basically tells that for memory to remember, it needs to be 7 plus or minus 2 to be memorable. So in your short-term memory, because this assumes that the information was processed when you first perceive it, like visual, uh, hearing, or touching. And then by chunks of information, a range of it, such as numbers, letters, or words. So it's similar to like programming or language. That is the data stored in the memory. They are able to remember on a few words or numbers that they have heard or seen. Chunks of information can also, another thing about this is that we better understand things if it's combined. So if it's just pure word, you won't understand it. But if it's a sentence, since it's a combined words that has its meaning, it magically help us to understand it better and remember it better. Or if two words combine has this like meaning, for example, um, you can think of any two words that has its own meaning, then you will be able because you just relate the concept. So that's another thing to take note of this. It's related to the concept of text or reading has provide more detailed information. So that could help you in searching and saving files. So maybe you could combine words to be able to understand the context faster because it's about like understanding the concept or the context faster. Chunks of information can also be combined. Items that are meaningful, for example, is it possible to remember the same number of two-word phrases like hot chocolate, banana split, rock music, cheddar cheese, leather belt, laser print, tree fern, flocky duckling, or cold rain? When these are all jumbled up, that is split belt, print fern, banana laser, cheese music, cheddar tree, etc. It's much harder to remember as many pairs. So you need to spend time linking two parts of the phrase together while trying to memorize them. This takes more time and effort to achieve, of course, if it's possible to do if you have time to spend rehearsing them. But if you're asked to do it having heard them only once in quick succession, it is most likely that you will remember only few. They don't just flash up on the screen and disappear, requiring the user to remember them before deciding which one to select. Memory load and passwords. Phone, online, and mobile banking allow customers to carry out financial transactions, such as paying bills and checking the balance of their accounts at their convenience. One of the problems confronting banks that provide these capabilities, however, is how to manage security concerns, especially preventing fraudulent transactions, such as bank spams where customers are tricked into transferring money out of their accounts. So here is the common things. It's also hard to remember, but it's helpful to recognize and know the basics of security questions for these applications. So number one, zip code, mother's maiden name, their birthplace, the last school they attended, the first school they attended, password of between 5 and 10 letters, a memorable address, not their phone, a memorable date, not their birthday. Much of the research on memory and interface design has focused on developing cognitive aids that help people remember. For example, reminders, to-do lists, and digital photo collections. The device they developed was a wearable camera that intermittently took photos without any user intervention while it was red, like see this figure, the camera could be set to take pictures at particular times. For example, every 30 seconds, the camera employed a fish eye lens, enabling nearly everything in front of the wearables to be captured. So here's basically a device that used for people that has amnesia. It records images like this, and then at the end of the day, it's saved to the computer, and then every week they review it. The digital image for each day were stored, providing a record of the events that a person experienced. Several studies were conducted on patients with various forms of memory loss using the device. The image that were collected uploaded to a computer at the end of the day. For the next 2 weeks, Mrs. B and her husband looked through these and talked about them. During this period, Miss B recalled of an event nearly tripled to a point where she could remember nearly everything about that event. So it works basically. Other technologies such as intelligent agents and smart pillboxes have been developed as cognitive aids intended to remind people with dementia to take their medication and whether they have taken it already. A novel approach is earables, which, when connected with smart objects, can act as memory aids. So a lot of technology are being developed to provide salient information, such as a robot that would uh, predict if the with dementia will gonna get their coffee. And then if they choose the sugar instead of milk, the robot will stop it. But it's still on research. Franklin suggests developing technology guidance system that could detect this before they have been executed. Letting the person know just in time via the earable, for example, to tell them to pick up the sugar shake shaker instead. However, such smart system in currently just design concept. Research need to determine whether it is possible to design such guidance system that is both accurate and useful. Social media companies like Google and Meta now enable people to revisit their memories they may have forgotten about through providing app features such as Year in Review. These present a snapshot of some of a person stock photos taken during last year. Which photos are selected might seem random but are likely to be based on a number of factors such as which were most viewed or liked. So I mean, you guys have noticed this in social media right now, like Facebook. They developed this technology that allows you to remember the most viewed story or picture you have years ago or post. So that's another thing or we remember this memories. Now, design implications, we should reduce cognitive load by avoiding long and complicated procedures for carrying out tasks. Design interface that promote recognition rather than recall by using familiar interaction patterns, menus, icons, and consistently placed objects. Provide users with a variety of ways of labeling digital information, for example, first, files, emails, and images to help them easily identify it again through the use of folders, categories, color, tagging, timestamping, and icons. Learning. So here we're in the part of learning. A learning is closely connected with memory. It involves the accumulation of skills and knowledge that would be impossible to achieve without memory. Likewise, people would not be able to remember things unless they have learned them. So the key here is that you need to remember things to be able to say that you have learned it. So basically, people think that memorizing is different. Some people think memorizing is not related to learning, but actually they are closely related. Within cognitive psychology, learning is thought to be either incidental or intentional. Incidental learning occurs without any intention to learn. Examples include learning about what words such as recognizing faces, streets, and objects, and what you did today. In contrast, intentional learning is goal-directed with the goal of being able to remember that. Software developers therefore cannot assume that users will simply be able to learn how to use an app or a product. It often requires much conscious effort. Moreover, it's well known that people find it hard to learn by reading a set of instruction manual. Instead, they much prefer to learn through doing. GUIs and direct manipulation interfaces are good environments for supporting this kind of active learning. by supporting exploratory interaction and importantly, allowing users to undo their action, that is, return to a previous state if they make a mistake by clicking the wrong option. So you cannot assume as a software developer that your audience has a lot of recall memory or understand your system. So we need to make it as recognizable or simple as possible, and then we need to you can or it's better for you to provide a GUI that allows them to manipulate the objects on their GUI and then undo or go back because these are the feature or the salient information that encourage learning. It encourages trial and error. There have been numerous attempts to harness the capabilities of different technologies to support intentional learning. Examples include online learning, AI tutors, and virtual reality. They are assumed to provide alternative ways of learning through interacting with information that is not possible with traditional technologies such as books. Another thing is that these capabilities, if we do not or we are not aware of human to computer interaction concepts. We don't know how it was created, that they are actually there because we have a limited memory. So for learning things, you usually need to focus one at a time to perceive, to hear, and to to touch because those are the senses one at a time. So you can only read one at a time. So basically, the key here is that learning takes time because it requires our memory, and memory can focus only one at a time. That's why it's important to read every day. In so doing, they have the potential of offering learners the ability to explore ideas and concepts in different ways. For example, interactive simulations, wearables, and augmented reality have been designed to help abstract concepts such as mathematical formula, notations, law of physics, biological processes that students find difficult to grasp. So because of the limitation of our memory, it's hard to to learn something because you can only focus one at a time. That's the reason why this use this combination of technology that could produce way of a new way of doing things or a better representation of how it works, like augmented reality or using AI to learn. An example is Sukal in 2021 study that show how integrating AI technology into physical classrooms enhance students' physical learning, self-efficacy, and their innovation to learn more deeply. The AR was designed to highlight and make more explicit aspects of a physical phenomenon by providing ideal light controls, design implications, design interface says that encourage exploration and tolerate mistakes. Design interfaces that constrain and guide users to select appropriate actions when initially learning. So another thing is that we are just humans, especially for those non-technical that does not have a lot of vocabulary about these computers. They will be confused of your system and they will not use it if it's not easy to use because it's just the psychology of it. It's a lot of overload for them and they are thinking a lot, not just the application, the learning of application. So that's why the application that's easy to use are usually the have the most users. Reading, speaking, and listening. Reading, speaking, and listening are three forms of language processing that have some similar and some different properties. One similarity is that the meaning of sentences or phrases is the same regardless of the mode in which it is conveyed. For example, the following sentence essentially has the same meaning whether one reads it, speaks it, or hears it. Computers are a wonderful invention. So people may think that one sentence could mean like a thousand different meaning. Well, that's true for reading, like scientifically, reading, speaking, and listening. For reading that, for speaking that, and for listening to that being spoken, it should have the same meaning. Okay, so it's contrary to that belief. However, the ease with which people can read, listen, or speak differs depending on the person, task, and context. For example, many people find listening easier than reading. Specifically, differences between three modes include the following. Written language is permanent while listening is transient. It is possible to read information if not understood first time around. This is not possible with spoken information that is being broadcast unless it is recorded. Although digital video recorders like TiVo enable rehearing of spoken information from broadcasts, allowing for dialogue to be replayed. So, through thousands of years, we are not able to record the spoken spoken words, but we can read that. So we are more adapted to like reading it than hearing it recorded, if that makes sense. Reading can be quicker than speaking or listening, as written text can be rapidly scanned in a way not possible when listening to serially presented spoken words. Another thing with this is that reading could be faster if you have learned to always read when you're learning. For example, me, I found it faster to read the concept than to listen to someone because listening for me is does not provide the health benefits of reading first, and then if I miss some words, I will have to like research it again. And then I forgot a lot that I heard and watched. That's just me, I don't know. But I think it's true for most people. Listening requires less cognitive effort than reading or speaking. Children often prefer to listen rather than to read the equivalent text online. The popularity of audiobooks and podcasts suggests adults also enjoy listening to novels, and so forth. Written language tends to be grammatical, while spoken language is often ungrammatical. For example, people often start talking and stop in mid-sentence, letting someone else start speaking. So the reason why the grammar does not is not as important in speaking is because it is not just designed to have the proper grammar because people stop speaking. You need to follow the basic conversation rules in speaking face to face or through your mouth. So it's different to written communication where you can edit it. Yeah, dyslexics have difficult understanding and recognizing written words, making it hard for them to write grammatical sentence and spell correctly. So people think that we are the same. I mean, if you really don't know someone that dyslexic, you won't be able to realize how lucky you are to be able to read. So don't waste that like superpower. Many applications have been developed either to capitalize on people's reading, writing, and listening, or to support or replace them where they lack or have difficulty with them. This include the following. So I think we have to continue. Let's finish this um, reading, speaking, and listening. Interactive books, apps that help people to read or learn foreign language, speech recognition systems that allow people to interact with them by using spoken commands using smartphones, tablets, and smart speaker. For example, Dragon Home, Google Voice Search, and home device such as Amazon Alexa, Google Home, and HomeAware that respond to vocalized requests. So another thing here is this speech recognition, which we've discussed in interface. Another thing with learning here is that, like, since we have discussed it, you have listened to this, you are able to learn that this system exists. Okay, basically, this will continue until the end of the human race, I guess, that people will continue to create technology or system like this to extend the representation of our brain that would not be otherwise possible without it. So we continue extending, and the world becomes so complex that these interfaces and these systems exist that we are not aware of, especially if you're not working in computer science. You don't know that this system exists because you just learned it the you just learn to use, for example, computer when for you were a kid. For me, I learned computer like playing games, so I know a lot. I have like a mental model that allow me to learn this fast, but it's not for everyone. Speech output apps that use artificially generated speech, for instance, written text to speech system for the blind, natural language interface that enable people to type in questions and get written responses, for example, chatbots. Interactive apps that designed to help people who find it difficult to read, write, or speak by reading aloud and proof, proofing written proofing written work like Ghost Real Writer. Haptics that help people who are visually impaired to play video games like Microsoft Haptic Controller. So there are different types of interfaces are available like this haptics, and there is also a chatbot if you like written communication. There's also speech output if you like spoken words. Design implications keep the length of speech-based menus and instruction to a minimum. Research has shown that people find it hard to follow spoken menus with more than three or four options. Likewise, they are bad at remembering sets of instructions and directions that have more than a few parts. So design applications, three or more or more menus are the hard to follow for spoken menus, and they are people are bad at remembering sets of instructions, directions that more than a few parts because again our memory can only focus one at a time, and then people don't have time to like learn all these systems that we created. That's why we need to make your system like work faster. For example, for me, I don't really have time to like learn, for example, some tools in my job because I also do other things. So that like laziness actually is preventing me from like being able to be more effective and to subsequently like automate my job. Why? Because if I like take time to learn that and focus clearly on what I need to do with that like tools and then learn that, I would be able to like suddenly automate that because I took time to learn it. So design implication, reading, speaking, and listening is different for different people. Uh, you need to know the audience and then learn to quickly adapt depending on, of course, the context and your goals. Accentuate the intonation of artificially generated speech voices as they are harder to understand than human voice. So AI are harder to understand. Research has shown that people find it harder to follow. Okay, so we're done. Basically, I just have few here: problem solving, planning, reasoning, and decision making. Uh, Cognitive frameworks. So here's the mental models, and then we have blocks of execution and evaluation. Information processing. That's a good topic. How we process information, and then inside that, we do have distributed cognition. We also have external cognition. Within that, we have cognitive offloading, computation, computational offloading, annotating and cognitive tracing, embodied interaction, which is the last part. So, which like dance or mimic others. So there, we were able to discuss the second part of this cognitive frameworks that very important in human to computer interactions. Again, guys, um, we discussed like the learning part, memory, and tools to like retrieve our data. Yeah, thank you for watching and see you on the next video. Guys.